So the following is an introduction to variables in Python, variables and namespaces. There's a few links here for more information, and some of the notes that are included are based on ideas included in these links. So in Python, we can think of values, in general, when we think about variables and how they're represented in memory and in the language, we can think of types as being by value or by reference. I'll be a little bit loose in my terminology here, but in many languages like C++, for example, we can think of variables as being named memory locations or boxes that hold values. So for example, if we write x is 5.5, then we have an object 5.5 with its own memory location, and it has a name x. If we then go y equals x, it creates a separate memory location, a different box, that holds the value 5.5 and is named y. And these are separate objects, so if we change x, it doesn't have any relation to the corresponding y. In Python, if we do x is 5.5, then we're creating an object 5.5 and then effectively tagging it with the name x. If we then do y equals x, I meant to write y equals x here, then we take the 5.5 object and also tag the same object with the name y. So it's a little different in Python. So here's an illustration. The ID function in Python shows the memory location of a given object. So here we have x is 5.5 and then y equals x. And when we print out the ID location of x and y, we can see that we get the same memory location for these variables. If we now set y equals 6.6, we're creating a new object called 6.6, and we tag it with the variable named y. And now we have that x and y point to different memory locations, because 6.6 is a different object than 5.5. For simple variable assignments like this, the difference is hardly noticeable, and we can pretty much ignore it, as we usually do. And this is because we've mostly been working with immutable objects, objects that can't change. So we're not actually, if we do what x is 5.5 and then y equals x and then y is 6.6, we're not actually changing the object. The object is 5.5 and the object is 6.6. Rather, we're creating a different object and assigning y to it. In contrast, this is in contrast to mutable objects such as strings or lists, for example, or dictionaries. So Python is object-centric, and objects come in two flavors: immutable, not changeable, those are numbers, strings, booleans, tuples, and mutable objects like lists or dictionaries. So here's an example. Import numpy as np, and then we have a as an array. If we do b equals a.copy, and then look at the IDs, well, we'll just do b equals a as the first go here. Then if we do a equals an array and then b equals a, then they're both referring to the same underlying object. B and a are both referring to the same underlying object, and we can see that when we go id a and id b, we get the same memory locations. Then what that means is if I change a0 is 101325, and then print b, then b is also 101325. And this is because they both point to the same object. So if I change element a, or if I change the first element of a, then b also reports that same element. If you don't want that behavior, if you want them to point to completely separate objects, then we should do a.copy. And now a and b, this will make a copy of b in different memory locations. So now when we run this, the ID for a and b will be different, 904, 824. Okay, and when we change a0, then print b, b is still 1234. which is what A initially was. So in Python, if you want to copy an array and have it in a completely different object, you shouldn't do a.b. b is a. You shouldn't do it b equals a. You should do b equals a.copy to make a separate object. Okay, so this just highlights what we were just looking at. Okay. Now, if we have a equals array 1, 2, 3, 4, and then we do b equals a times 2, this, in fact, is a completely separate array, a times 2. And when we do a 0 is 1, 0, 1, 3, 2, 5, then b will be still 2 like it was originally. And if we output the ID for a and ID for b, in this case you can see that there are in fact different objects. So without the 2, the times 2, they're the same object. With the times 2, it creates a different object, and a and b tag different objects. Okay, let's look a little bit more at function arguments and scope. So in Python, there's different scope levels. We have the built-in level scope, where all the keyword names live, like def, for example. In a given module, we have the module level scope. We can call that the global scope. And then if we define a function, we have the local function scope. So when we're dealing with variable names in Python, anything in a lower scope can see variables that are defined in a higher scope. So the Python built-ins can be seen everywhere. In a given module, all variables can be seen, all module level variables can be seen locally inside of a function. But you can't go the other way. So local variables aren't generally known in the global scope, and local variables normally can't change global scope variables directly. So if inside of a function, we normally can't rebind a global variable to a different object. Instead, we'll end up making a different variable with the same name that's in that function level scope, and that will bind to a new object. So that is like same name, different variable bound to a different object. And you can think of this like people in a classroom. You've got two different people with two different names. This works because they're different scopes. Jane 1 is different than Jane 2. They both have the same name, but they're different people. Okay. So here's an example. We have the same variable name can be used to tag different objects in different scopes. The variables are different, but the names are the same. So again, think of two different people with the same name. So in the following example, outside the function, we're going to create an immutable object and tag it with variable x. And x is a global variable. Then we're going to call a function f of x. Inside that function, we're going to go x equals 6, creates a new object and tags it with local variable x. The same name, different object, different scope. And we're not allowed to change the global tag object binding to 2, so it's a local object. And then finally, the outer object will still exist. So let's go ahead and look at this. So here's the code. So we have x is 2. Create this outside object, and then we're creating this function, and we call the function. So outside, we have an integer object 2 that's tagged by x. Then when we call the function, x is 2 is passed in, and when we print it, we get x top of function is in fact 2. Then we go x equals 6, and this x is local to the function, so we're not changing the outer x is 2, we're only changing the local x is 6. and then we print that, and it's 6 at the end of the function. Then after the function call, this local scope is done, and we print x final, and it's still the same x here, and it has a value of 2. So these steps 1, 2, A, 2, and 3 are 1, 2, 2A, and 3. These line up. Okay, so we could include x and ID x, maybe there, and ID x here, and x comma ID x to see what these show. So initially we have x2. When we pass that in, we get that ID 544. When we're not allowed to change this global variable, so when we go x equals 6, we get 672, a new object. Then when we print that, we get the ID. When we come back to the bottom, we're back to the original object. And we can print this outer print ID x as the very top. We get 544. It's the same one that gets passed in. So inside the function, it's the same object. So you can trace through what's happening in these situations by simply looking at the values using print statements and using these ID functions. So again, step 1, step 2a, step 3 is illustrated visually in what's happening here. So you have a module level x, then inside the function we create a new object with the same name, and then when the function's over, we're left with our final module level x variable. Okay, a second example is similar to the first, and here we're creating a mutable object. So instead of x is 2, where 2 is immutable, we have a mutable list object which can change its contents. And we pass that to the function, and in this case, the function then tags the same object with local variable x, and then when we change it inside, it's still changed outside. So here we have my x is 2, 2, f of my x. Now my x is locally called x. When I change x1 to be 6 and then print my x, it's still changed. So this x equals 6 inside the function is in fact affecting the value that we pass through the function argument list without there being any return statement. So we're effectively changing my x argument in the function. We set it, we pass it in, it gets changed, and then that change, x is 6, persists outside. And that's because we're always dealing with one mutable object. Okay, so that's a basic introduction to some ideas of variables and scope in Python.